Hello and welcome to Chemistry with Mr. Olson. Today we're doing basic stoichiometry, question 5. Alright, so here's our worksheet and we are asked, we're given a reaction. Aqueous solutions of barium nitrate and ammonium carbonate are combined to produce solid barium carbonate, that's the precipitate, and aqueous ammonium nitrate. Write the balanced equation. We do need the balanced equation to do stoichiometry. So, the first step is to figure out the chemical formulas of these 4 chemicals, these 2 reactants and the other 2 products. So, these are ionic compounds, and so we need to identify the ions. Barium is found in the periodic table. Let me get my periodic table. Barium is found right there. It's an alkaline earth metal, so it gets a +2 charge. Nitrate is a polyatomic ion. It has a -1 charge. Ammonium, NH4 with a +1 charge. Carbonate, CO3 with a -2 charge. And by using those 4 ions and combining them, we get the chemical equation. We get each formula. Barium nitrate, 1 + 2 with 2 -1s. So this is the formula. It did tell us that these were aqueous solutions, the reactants. So there's the barium nitrate. Ammonium carbonate, 2 ammoniums, 1 carbonate. Again, an aqueous solution. And react to form solid barium carbonate, +2 and -2, so the formula is BaCO3, it's a solid, and aqueous ammonium nitrate, +1, -1, so there is our 4 chemicals. Now we're not quite done. Once we get the chemical formulas correct, it's time to balance. It's always good to balance in pencil in case you want to make changes or start over. We need 1 barium on each side. We have 2 nitrates. Treat polyatomic ions as units. In other words, don't balance the nitrogen and oxygen separately. So we have 2 nitrates on the reactant side. We need 2 nitrates over here. So let's write a coefficient here. Notice we are now, when we balance, we're just adjusting coefficients. And in fact, if you check things out, it's now balanced. It was an easy balancing problem. Okay, now that we have the balanced chemical equation, we can proceed to a stoichiometry question. This one asks for grams of ammonium nitrate. How many grams of ammonium nitrate form when 220 grams of ammonium carbonate react? So we're given the amount of ammonium carbonate, this reactant, and we're asked how much product do we get in grams. So, stoichiometry from grams to grams, we use our mole roadmap. Grams of X to moles of X to moles of Y to grams of Y. So we will need 3 conversion factors: a molar mass, a mole ratio from the balanced chemical equation, and then a different molar mass for substance Y, the second substance. All right, let's do that. The way this is going to look, of course, is like this. Grams of X to moles of X, to moles of Y, to grams of Y. We have 3 conversion factors, 2 molar masses and 1 mole ratio. All right. So let's start with the given. 220 grams of ammonium carbonate. I'm going to abbreviate that AC, otherwise it gets very messy. It's a long formula. That's our given. Grams of X. Now our first conversion factor. Out of grams of X, grams of AC, into moles of AC. And this is the molar mass of AC. It's always grams per 1 mole. Grams per mole. How many grams per mole? And we have here on the left, we've got the molar mass of ammonium carbonate. Here's the formula. So 2 N's, 8 H's, 1 carbon, 3 oxygens, And it adds up to a grand total of 96.0 grams per mole. Grams per mole. So, that's the number we write here. 96.0 grams per mole. All right, so that takes us out of grams of AC into moles of AC. That's the first step. But the question wants us to talk about a different substance, and this is what happens with the mole ratio. We get out of talking about moles of AC, and we start talking about the substance we want. Ammonium nitrate, I'm going to abbreviate that AN. Now, how many moles, what's the mole ratio? That we look at the balanced chemical equation. It looks like we look at the coefficients. 1 mole of ammonium carbonate reacts to form 2 moles of ammonium nitrate. So 1 mole of AC corresponds to 2 moles of AN. That is our mole ratio. And so we've gotten out of moles of AC, and now we're talking about the substance we want, ammonium nitrate. But we don't want moles, we want grams. So that, of course, is our third conversion factor. Moles, out of moles of AN into grams of AN. And it's always grams per 1 mole. Now, what's the molar mass of ammonium nitrate? Ta-da! I already wrote it down here. Ammonium nitrate, NH4NO3, that's 2 nitrogens, 4 hydrogens, 3 oxygens for a grand total of 80.0 grams per mole. This is our conversion factor from grams to moles or vice versa. In this case, it's out of moles into grams. And so it's 80.0 grams per mole. And so we write an equal sign, and then we do the calculation, and we come up to 3 sig figs. We started with 3 sig figs. 367 grams of ammonium nitrate. Ammonium nitrate. NH4NO3. Couldn't fit that on the screen, but that's what it is. I like to write the chemical with my answer. All right, so that was our first problem. It was a grams to grams. That is the most complicated one. Grams to moles to moles to grams. And the computation looks like this. Grams of X, out of grams of X to moles of X, out of moles of X to moles of Y, out of moles of Y to grams of Y. 3 conversion factors, 2 of which are molar masses, and 1 is a mole ratio from the balanced chemical equation. Okay, that was a complicated problem. Let's try C. How many moles of ammonium nitrate will react with 110 grams of ammonium carbonate? Okay, so now we're given the grams of ammonium carbonate, the reactant, and we're asked to calculate the moles of this product. So we start with our given, 110 grams of AC. And let's see. In this case, we're going from grams to moles to grams of X to moles of X, moles of X to moles of Y. So it's this. We're starting with grams, going to moles of X, and then moles of other substance. It asks for how many moles. So we take that and we multiply it by our first conversion factor out of grams of ammonium carbonate into moles of ammonium carbonate. It's always grams per 1 mole, and we've figured out the molar mass of ammonium carbonate is 96.0 grams per mole. It's still 96.0 grams per mole. It's a characteristic of the substance. And now, since we want moles of ammonium nitrate, this is we need to get out of moles of ammonium carbonate. We always set up our conversion factors so that the units cancel, into moles of ammonium nitrate. And looking at our balanced chemical equation, 1 mole of ammonium carbonate produces 2 moles of ammonium nitrate. So it's a 1 and a 2. And that's the units we wanted. So we stop there, write an equal sign. I like it if we show our unit cancellations, helps us understand what's going on. And we do the calculation, and we get our answer, which is 2.29 moles, 2.29, and our units, moles of ammonium nitrate, NH4NO3. And that is the correct answer. Once again, we started with 3 sig figs, so we end with 3 sig figs. Question D, a little bit easier. How many moles of ammonium nitrate can be produced from 3.00 moles of barium nitrate? Well, this is moles to moles, so it's only one conversion factor. This is the simplest case here. We're going from moles of one thing to moles of another. We just need the mole ratio. So let's start with our given. That's 3.00 moles of barium nitrate. Our conversion factor takes us out of moles of barium nitrate into moles of what we want, which is ammonium nitrate. And we look at the coefficients. 1 mole of barium nitrate gives us 2 moles of ammonium nitrate. So that's a 1 and a 2. And that's the units we want for our answer. So we put an equal sign, our units cancel, and we do the math. 3.00 times 2, conversion factors don't affect sig figs, so we get our answer 6.00 moles of NH4NO3. And that is our answer. One more to do, which is this one, also a moles to moles conversion. So we have our given 6.00 moles of AC, and we know we only need one conversion factor, the mole ratio. We get out of moles of AC into moles of BC, barium carbonate. And let's look at the mole-mole ratio. It's 1 to 1. So very simple math here, and our answer is 6.00 moles of barium carbonate, BaCO3. All right, just looking at the last problem, how many grams of barium nitrate are needed to produce 5.0 grams of ammonium nitrate? This is our given, and it's going to be grams of X to moles of X to moles of Y to grams of Y, our stoichiometry roadmap. So the calculation will look something like this, very similar to what we did in 5B. All right, so that is our stoichiometry workshop. I hope you've enjoyed chemistry with Mr. Olson. Have a beautiful day, and ta-ta.